And welcome everybody to the Daily Space Weather. Lots of exciting stuff going on today, including Filaments, Sunspot 2803, Geomagnetic Unrest, and features galore. Thanks for tuning into the Smash News Network, by the way. Least busted name in news. First thing we're doing is looking at the sun in 304 angstroms here, and you can see filaments galore. Filaments up here, moving around, filaments down here, coronal hole, wind stream showing up at the Earth right now, geomagnetic unrest conditions. Too much stuff to name, so check it out. Here's the fade from 304 angstroms to magnetogram. And while the main umbra on Sunspot 2803 has degraded, we see more umbrae forming there. So also I see a bit of a Mr. Mean Guy sun face here going on. Check it out. It's a mean smiley face. And it's been creating geomagnetic unrest. It's all because of this coronal hole underneath my pointer. Great view there in 193 angstroms. And we've got some more spectacular videos here. Here's 304 angstroms on HelioViewer. It's going to look a little bit differently than the SDO browse data that we showed earlier. And here's a close-up of the sunspot. And I would note that this sunspot has now turned into a beta-class sunspot. So even though the main umbra has shrunk, we've got additional umbrae have grown around the main umbra. And we'll explain that later toward the end of the video. Too many other spaced-out things to cover. And thanks again to our viewers for tuning in. Here's a view of just the north hemisphere. And you can see lots of activity going on up there. And we don't see any coronal mass ejections yet, although the possibility for coronal mass ejections is indeed quite high right now. And if one happens, we will be making a video about it. None of those filaments have appeared to eject yet. I checked lots of different data points. And here's one close-up of Sunspot 2803 in 94 angstroms. And we'll save the rest of our close-ups of this for the end of the video. Great view there. 10 images per minute. 10 images per minute, folks. And you can find 10 images per minute on also 131 angstroms. 94 and 131 angstroms have a higher temporal resolution than the rest of the wavelengths shown on the SDO. Next, looking at positions of things like planets and planetoids in the solar system. There's where we expect things to be in a week. And we've got a baseball diamond-like shape going on here. And you know diamonds in baseball are very, very scary. Very scary and spooky. Here's a star chart. Today the sun will be passing through Sagittarius and Scorpius and Libra and Virgo and Leo. I don't know if that means anything to you or not. I find it interesting that cosmology is starting to look more and more like astrology the more we learn about it. The 10.7 centimeter radial flux, a proportional measurement to sunspot number, now up to 73. So as forecasted, an uptick here in solar activity. There's the 1 year chart of the radial flux, which is this upper black line right here. And you can see how proportional that is to sunspot number. The coronal hole wind stream arrived early. And as you can see there, a geomagnetic storm was forecasted, has not showed up. And we are still in a condition of geomagnetic unrest because of all those high-speed protons coming out of that coronal hole. Let's talk volcanoes. Here's a thermal image of Mount Aetna, which has finally chilled out over the past 12 hours. Aetna's eruption ends. after various lava fountaining paroxysms and all kinds of, I think a new crater was formed and lava flows, and a 20 and a 30,000 foot ash plume actually produced there. I know one town was covered with ash. Mount Aetna has finally chilled out. Sorry, folks, we can't always just talk about disasters. Sometimes we have to talk about the ends of disasters. As spring approaches and most power is returned to Texas, let's see what else is erupting when it comes to volcanoes. Quite a few actually are erupting. So Suwanosejima is exploding, 4,000 foot ash plume there. Raung on East Java, 14,000 foot ash plume there. Popocatépetl, 20,000 foot ash plume in Mexico. Fuego in Guatemala, 14,000 foot ash plume as it explodes. Sangay also exploding, 20,000 foot ash plume there. Revenador exploding, 14,000 foot ash plume there. And continuous ash emissions from Sabancaya are a reminder not to pole vault the caldera or to make a fool of yourself on social media. Next, looking at earthquakes over the past 24 hours. No major earthquakes, although a significant earthquake here in Oklahoma, a 4.2 magnitude near Manchester. Please leave us a comment if you felt that quake. North of Enid and south of Wichita. It may have actually been felt in parts of Wichita there. 4.2 magnitude earthquake happening just south of the Kansas-Oklahoma border. Let's continue up the list. And if there's anything we don't note that you want to note, put it in the comments section, as these videos are a collaborative effort. And thanks to our viewers who leave comments, especially ones that aren't insane. No, seriously, thanks everybody who leaves comments, including the insane ones. Leave a nice comment, leave a mean comment. You won't hurt my feelings, I promise. So there's a deep quake in Peru of 4.1 at 142 kilometers depth. Another deep quake at Tonga, a 4.6 magnitude at 249 kilometers depth. In the deep quake capital of the world. I think the largest of the past 24 may have been this 5.6 near Vanuatu, very close to the surface at only 6.7 kilometers depth. And if you're viewing from New Zealand, leave us a comment. Hey, Eddie Dawkins, did you feel that quake? Leave us a comment. Retired pro cyclist Eddie Dawkins. You may see his posts on Instagram if you follow us there. Instagram.com/smAshomash. And a deep quake at Chile, a 4.5 magnitude. By the way, this smAsho stream was brought to you from twitch.tv/smAshomash. Twitch.tv/smAshomash is where we stream most of our daily space weather videos. Next, thanks to our patrons. Thanks to our new subscribers over at Twitch, by the way. Thanks to our patrons, most of all, for increasing the probability that this content will continue to exist, be publicly visible, and be free for the world to view. Please consider becoming a patron at patreon.com/smAshomash. If you want the world's earliest alerts on things like space weather, check us out there. Look for more promotional material coming out as we've completely changed our marketing process. So, since that's all changed, look for marketing material. We'll be putting it all over the place. And coming soon, completely different marketing strategies. Also, don't forget to press like and subscribe if you're viewing on YouTube. And we don't always read comments, but here's a comment that will actually read on the space weather video. Ellipsis truncate the resistance.video comments, we need to ask whether and how the Earth conscious through the beings first. Is bacteria a feeling? There may be energy beings over there. We may be sun's conscious extremities while it's just a blob of liquid hydrogen. Isn't the whole solar system part of its electromagnetic body? A condensed radiation. It's conscious in some way when it's alive, but it's hard for me to tell the source of my own consciousness, so I don't know. We don't always read comments, we typically don't, but leave one. Maybe that's incentive to do so. But whatever you do, make sure you press like and subscribe, press the notification bell, and please share our content on your social media, and thanks to our viewers who've been doing so. And thanks to our viewers who've seen the hilarity on Facebook. Thanks new subscribers, old subscribers, friends, foes, science noobs, and science pros for tuning into the videos. Thanks to our new BitChute subscribers, as well as our audience continues to grow over there, as well as on Facebook. Also, make sure you visit our own webpage, as we saw the writing on the wall years ago and decided to become alt tech. Since big tech is in the process of self-destructing as we speak, head to smAsho.com. And you'll be able to find our links to our social media there. We're on Minds and Gab when it comes to alt tech. Also Facebook, Twitter, Locals, Facebook, etc. And visit our links: smAsho merch, smAsho forum, smAsho store, and Smash store. Today's featured shop is the smAsho merch shop. So if you click this link right here, smAsho merch, it'll send you to this shop. And today's featured product is the Fauci fraud bath mat. If you would like to put your feet on the face of this fraudster right here every time you get out of the shower, pick up our Fauci fraud bath mat, or perhaps a t-shirt or something else. If you'd like to go tell your friends and foes about how Dr. Fauci is a fraud, committed fraud, and yet the world continues to listen to him because reasons. Let's do a cosmology segment, as we've got some interesting stuff to talk about here when it comes to cosmology. Is it geology or is it cosmology? Are you familiar with the Lechamp event? Well, the Lechamp event was a 440-year geomagnetic excursion where the pole was reversed for about 440 years. This caused an increase in cosmic ray flux on the planet and an increase in isotopes beryllium-10 and carbon-14. These are two more important aspects of cosmic ray flux. It doesn't just cause cloud nucleation and various chemical synthesis. It causes radioactive isotopes to show up measurable on the surface. The Lechamp event. Why are we talking about it? Well, because there's a new article that's come out about it. We'll talk about it in a minute. The real question is, what is the Earth's core composed of? Anybody? Leave us a comment. Let us know if you think it's made of iron and nickel or of something else. And I won't conjecture about it on today's Daily Space Weather video. This cosmology segment is featuring a story from SciTech Daily about how Earth's magnetic field reversal 42,000 years ago triggered a global environmental crisis. Now, we know this based on a lot of different information. Number one, igneous rocks. When a volcano erupts and creates new lithosphere, we can analyze that new rock created to figure out what the Earth's magnetic field was doing during that time. And it appears that the Neanderthals went extinct around this time, and all kinds of other environmental things happened on the planet. If you want to read the article about it, it's on SciTech Daily. And what you really have to ask yourself is this geology or is it cosmology? Or is it both? Perhaps a combination of both things. The global environmental crisis 42,000 years ago. And we'll actually feature more on this later in the video in the meteorology section, so stay tuned for that. In the meantime, how about a random number between 1 and 1031 using our quantum number generator from qrng.anu.edu.au/dice-throw. It's a quantum number generator, and today's quantum number is 495. So we'll head to the Neil Gorell Swift-Bat X-ray Observatory, and we'll scroll down to 495. Now, this is an X-ray monitor, and this is how we're looking at a whole bunch of different cosmic objects. So this one's a pulsar, pulsar J1509-5850. There are the X-ray transient bursts from it. It's a pretty weak X-ray source, it looks like. So here's the 30-day chart, here's the 3-day chart, and there's the 16-year chart in the upper right. Pretty consistent, a little bit of fluctuation there, and let's see if we can catch some visual analysis here in a couple wavelengths. Here's the view on Aladdin light, which is optical. Nothing showing up there. Let's see if it shows up in infrared. I would have to say I doubt it. Nothing showing up in infrared light there. Maybe a tiny blip, barely a pixel. but it'll probably show up on the XMM Newton as it's an X-ray source, and there you can see it's a pretty weak X-ray source. How about on Chandra? And it looks like it may be showing a pulsar wind. So this is most likely a pulsar wind nebula right here, folks. As you can see, it looks just like a bow shock. So that may tell us some insight into things like the magnetic fields and the interstellar environment around this pulsar. Pulsar J11509-5850 looks a lot like a pulsar wind nebula to me. What say you? Perhaps even seeing a magnetotail here. I certainly hope so. Perhaps further analysis on that later. Pulsar J1509-5850. Man, what a fantastic view. And that's today's cosmology segment. Let's move on to additional data. We don't see any major solar flares over the past 3 days. 1 B-class flare yesterday, and 3 B-class flares on Thursday. No proton strikes, at least not significant ones. No coronal mass ejections yet. We'll keep you posted if there are any. Next, we'll look at the real-time solar wind. We just saw another increase in the solar wind speed. It looked like it was coming down, and now it's reached new highs here, up to 539. Just about where we saw the highs earlier. So another coronal hole wind stream here showing up. And we see significant density associated with this also. So this is an ongoing event, geomagnetic unrest, caused by all of those high-speed protons from that South Pole-oriented coronal hole. Has the current solar wind density at 10 protons per cubic centimeter. Solar wind speed, 528 kilometers per second. And I'm just checking the life of the stream here. I did see some bandwidth issues. We hope it's working out okay. And you can see we were in geomagnetic unrest conditions for about 12 hours yesterday, and then we've gone back in today. So it's like a double pulse at least coming from that coronal hole wind stream as protons are ejected through this low temperature portion of the sun known as a coronal hole. Here's a close-up of it. And this is the coronal hole that is causing that geomagnetic unrest. I have no idea what the number is if you want to figure out the number of that coronal hole, or if it's making multiple appearances here. Head to solon.info/solar. Also a view of this filament in this area. All around here. Large filament, as well as a smaller filament down here. Again, likelihood of coronal mass ejections is pretty high right now, folks. So again, we're in geomagnetic unrest. We're going to show you the magnetosphere movie for density. Keep in mind this only shows between 0 and 4 protons per cubic centimeter. So it's a little bit of a lack of data there. In any case, high density in the bow shock region for sure, as well as in the closest part to the earthly magnetotail. Here is the pressure. So a bit of a high pressure environment right now. Not quite the geomagnetic storm conditions. And that coronal hole wind stream arrived a bit early, perhaps because of previous activity. I'm not going to try to get into the astrophysics of that right now, as it is the daily space weather. And the way we forecast is by understanding the physics. Next, looking at magnetic perturbations on the globe. And we're looking at the polar view, as we've been doing recently. You can see the North Pole appears to have 2 geomagnetic poles, one over Siberia, one over Canada. Main perturbations on this past 4 hours of data, which is what we're showing here, this is 4 hours of data, were over Siberia. So perhaps some auroras sparked from that. Perhaps we'll show you some images of those tomorrow once they get uploaded to the internet. We see some significant changes to the Earth's B field. Geospace delta B is a reference to change in the Earth's B field. We're looking at nanoteslas here. And we also see some significant perturbations over the Canadian North Pole. as well as the south geomagnetic pole, which has crept into the Indian Ocean. So here's the auroral forecast. And you can see those magnetic perturbations have kicked up some auroras over Siberia for sure. And shout out to our international viewers. And as the solar wind speed kicks back up again, right there you can see some additional auroras being created. Keep in mind this is just a model, folks, and the closer to red you see there, the more likely you are to see auroras in those locations. Next, the GOES magnetometer. You can see these low readings as I forecasted yesterday. No surprise to me or the rest of our viewers. Cheers. So there's a 3-day chart of the GOES magnetometer. And we may be moving out of this high plasma region. We may see some very high readings. We may even see this scale expand on the GOES magnetometer. Let's take a look at the Gong2 data to check out things like the polarity of the heliospheric current sheet. So here we go. It's the top view ecliptic plane field plot. And again, I am expecting to see high GOES magnetometer readings here as a result of what we're looking at. So without going too in-depth into that, since it is just the daily space weather video and not some sort of a cosmology segment, that's 2 hours and 15 minutes old, by the way, folks. It's the top view ecliptic plane field plot, and we will be solidly in the South Pole current sheet tomorrow when we make the daily space weather video as well, because of where activity is located and so on, magnetism, and all of that. So here's a line of sight field plot. And if you look over on the left side there, you can see the B field being pulled up. The blue lines are the sun's B field, and you can see this line being pulled up here toward where that sunspot is. This one also shows a solar magnetogram and poloidal fields, which would be these fields. The polar fields, those are poloidal fields. And here's a line of sight coronal hole plot. Again, that red coronal hole just moving past the Earth-facing zone there is the supplier of the current state of geomagnetic unrest. Last visualization of magnetism here, it's the coronal field plot, the magnetic field plot of the sun's atmosphere, a chaotic place. And you can see those purple potential field surface source lines coming out of that Earth-facing coronal hole there. Great view of that. Here's a diagram of the atmosphere in kilometers to show folks where the Ionosphere layer is. It's right there, just over 300 kilometers altitude. Here's another diagram, and we're showing the Van Allen belts here and altitudes in miles before we move into the electrons section. And we see some anomalous charging here despite low levels of electron flux. Anomalous charging hazards here over places like Mexico and the Central Pacific. And there's the electron flux as forecasted at low levels. Low levels of electron flux, and when you see this flat line here at the bottom, that is because it is only able to measure down to that level, which is like less than 100 pulse flux units. And this will remain low until the coronal hole wind stream ends, and we'll keep you posted as to what will happen next. To put it in context, here's a 1-year chart of that. That is available at solon.info. And before we move on to the total electron content visualization, I'll just check the life of the stream once again, and it looks okay to me. So we see some very high levels of electron flux here in very concentrated locations, such as just west of northern South America, right about here. I'll let it play through a second time so you can see that. And this will give you an idea of where GPS errors will occur. So quite high levels there, despite overall low levels of electron flux as measured by the GOES magnetometer. This is the entire air column up to your GPS satellite. Here's a total electron content forecast. I would tend to agree with that over the next 3 days. Maybe even higher levels than this once this does go up. But that's all dependent on when the coronal hole wind stream ends, and that's pretty difficult to forecast. So let's move on. Here's the visualization of the ionosphere. And this is the first time I'm seeing it. So let me just say, Oh my God! Some sudden charge ups of the ionosphere actually there. And this is showing you megahertz, which is millions of vibrations per second. And it is a little bit anomalous here. It's suddenly charging up and suddenly charging down over places like the area west of Hawaii, the Western Pacific, and the Himalayas. And here's the latest image, that one coming in at 10:45 Universal Time, looking normal there. And we're coming at you a little late today. Now, let's talk about the diamagnetic nature of water. Were you aware that strong magnets will repel water? Well, here's a little video about it. So if you float a test tube of water and you apply a strong magnet to it, folks, it will actually repel the water, as you can see in this demonstration. Now, we'll be talking about this more at a later time. But before we go into meteorology segments, I figured I would show that, as our viewers may not be aware of this. It does figure into things like the jet stream. And here is the jet stream of the Western world. And look at how chaotic it is around South America. This whole area here. That is barely a that's not even a jet stream, folks. I mean, you could say this little section right here is, but besides that, not really a jet stream in the southern hemisphere. Extremely chaotic. And some very concentrated jet stream up here in the North Atlantic. How about the jet streams of the eastern world? Well, here they are. And we still see some extreme bends there just east of Australia. Highly concentrated jet stream in the Western Pacific, right around this area. Massive anticyclone here in the Pacific Ocean, and indeed we do see high pressure there, I believe, if my memory serves. And to quote Einstein, never memorize something which you can look up. Don't forget to look up, folks. And if you are looking up, you may notice that there's almost no lightning happening 2 days in a row here. It's a global lightning map here, lightningmaps.org. It's in real time, and practically no lightning strikes. Remember, folks, an anomalously low reading on your graph may be even more important than an anomalously high reading on your graph. And indeed, there is not an anticyclone over the Western Pacific. It's actually over the Eastern Pacific here off the coast of California. You can see that powerful clockwise rotating high pressure zone under my pointer, as well as a strong double low there in the North Atlantic. Let's advance this till tomorrow. It's the Gfs forecast for pressure. There's where we expect pressure, atmospheric pressure, barometric pressure, to be at 1 p.m. Eastern Time. It looks like we'll have clear skies tomorrow, as we have high pressure over the entire eastern portion of the country. And some warmer temperatures in Texas, thank goodness. Here's a satellite animation of the cloud layer. Lots and lots of low clouds here over the Western Atlantic as well as the Gulf of Mexico. South of Baja California, you can see low clouds down there as well. Here's the water vapor map, and back to the cloud layer, and back to the water vapor. Lots of moisture there over the northern Rockies. Here's a U.S. Doppler radar map, and we're still getting some snow showers across the Northeast. And some heavier snows in the northern Rockies there. Texas has solved most of its power outages. However, there is a need for things like plumbers and construction workers. If you're a contractor looking for work, maybe head to Texas. There are a lot of burst pipes. And thanks, Smash Team, for tuning in and promoting us instead of promoting fraud. Please don't forget to press like and subscribe and share with your friends and your foes, even your neutrals. Thanks to our new subscribers, our loyal subscribers, and thanks to people who don't like us. Here at the Smash News Network, there's a reason why we're the least busted name in news. It's because we don't have an agenda and we don't promote fraud. So let's take a look at some extremely high-res images here of Sunspot 2803. And thanks for leaving a comment, Amp Mods. Bye to you. So here's the solar intensity gram, and we see multiple umbrae here associated with Sunspot 2803. So while it has split in two, it has now evolved into a beta class sunspot, I believe. Here are the magnetic fields. And nope, it's an alpha class sunspot. These are all North Pole oriented umbrae, folks. So that is still an alpha class sunspot as far as I can tell. Again, there are the magnetic fields. And it looks like some additional activity rising there. And again, the likelihood of coronal mass ejection is fairly high here. Let's take a look at the rest of our close-ups of Sunspot 2803. Here is 193 angstroms. Great view of that, as well as some trailing filamentary activity happening back there. You can see it at the very end of the video. You can see a filament right in this area. I'll let that play through a second time. Or is that a third time? I was not counting. And here's 171 angstroms, my favorite wavelength. In any case, thanks for tuning in, folks. Remember, stare at the sun, don't drink, but if you do drink, don't drive. And since it'll never be now again, we'd like to welcome you to the Neo-Renaissance. Well wishes, may that solar wind be at your back.